especially since I have nothing personal to say, or it's not that I don't have any personal things to say, but I'll not say them. But basically, I kind of thought that I've been giving a few of these talks in birthday fests of various people, and somehow I never say anything personal. I try to somehow I think that I'm giving some tribute to their work in a way, and that's what I want to do very shortly now. So I want to reflect on some aspect of Ronitt's work, or at least the way I view it. And it's only one aspect. There are many aspects. So it's going to be totally technical, but not very technical, but conceptually technical in a way. So I want to say that really, if you think of it, the celebrated works of Blam Luby and Rubenfeld in Sudan, they really started property testing, thinking, following the path of program checking, or viewing it as an extension of program checking. And also our work with Dana and Shafi and myself also started by a different path, but also I want to say that there is something similar in both paths. It was more of a computational learning theory path. The point is, in both places, you view the object of studies as programs or as concepts, and these are functions. So you view these objects as functions, which means that in your mindset, the length of the input to this function is really the scale of efficiency. So if you want to talk about an object, about an efficient algorithm, you will say that it is polynomial in the length of the input, and the input here is not the object itself, but rather the input that the function takes. So this means that actually you are looking, the object, as I wrote here, is exponential in the efficiency scale, and the efficiency is really polylog in the domain or in the object size. So if you are trapped in a way in this way of thinking, you will never get to things like distribution testing, which typically requires much even for a problem like testing uniformity, you need to take a square root of the domain size or of the support size, and you're not going to go this way if you are thinking in this direction. And the point with the initial works of Ronitt in this area, which started distribution testing, is really to do a shift of a scale and to think of the object itself as the size of the object as a scale of efficiency, and then to seek sublinear complexity. And this is really what is doing a kind of magic, or I think this has elevated really all the area of sublinear complexity and property testing to where it is now, in my opinion. Actually, I would insert also a comment here. I really object strongly when people define testability as being as having complexity which depends only on the proximity parameter. Of course, it's a central feature that an algorithm has a complexity which depends only on the proximity parameter. So I want some name or some notion for this, and I will call it size oblivious complexity, or proximity oblivious, or proximity depending complexity, or whatever, but don't call it testability, because testability can have the whole point of my whole point of a shifting scale really is lost if you define testability in this way. So the point is that you really want to depend, you want to allow the possibility of depending on the size of the object, but you want this dependency to be moderate, or to be sublinear, or to be whatever. And as I wrote here, an analogous step was also taken in the bounded degree graph, model. And there, if you start thinking about interesting problems like bipartiteness or things like that, then you are really forced to talk about the square root of n time algorithms, and n is now the size of the object. And also, it goes beyond this. You now you see that you moved from looking at objects which are programs or functions or concept classes in the learning stage, kind of huge objects. You move to looking at objects which are really at human scale. So it's a graph. So it's a huge graph or a very large graph, but really talking about taking a square root of it is already an improvement. So just let me finish by musing that there are also analogies in complexity theory for this notion of changing scale. And if you think about, this is an artificial example, but if you think about translation lemmas, which says that if you have some inclusion in some levels, and you have an inclusion also on a higher level, usually, it's not a genuine example, but if you think about the fact that there is a fine-grained complexity and it uses the exponential time hierarchy in order to derive lower bounds, then you see also here a change in scale. So somehow here goes the same direction as in Ronitt's work. It goes from exponential to polynomial. And if you think about yet another example, if you think of the original result of Babai, Fordnau, and Lund about nx equals to MIP, or about having a PCP with polynomial randomness and polynomial query complexity, then it is a nice result, but it's not clear what it tells us about our life, about human scale. And the point is that the scale down in this case by BFL and FGLSS, I will not say all the words again, so it allows us to say things about NP. So there is again the notion of the importance of a scale down or of scaling in general. So I think that's a conceptual point in my mind, to be able to realize that somehow a scale down is possible or is useful or something like this. And that's, of course, something which is being disregarded by people who are very technically oriented, but I'm conceptually oriented, so I like it very much. So I think I'm done at this point. Let me just insert a nice word, because I missed Ran's birthday. I want to defend him and say that he's one of the nicest guys I know. Of course, also Ronitt, but I want also to say something nice about Ran.
Thank you so much, Oded.
I should stop share. Okay.
For the previous talks, we had people waiting in front of their computers. That's why I didn't take any questions, but we can take one question if there is one now.
Why does he think that Ran needs defending?
Why do you think that Ran needs defending?
Am I on? I agree with Shafi. He doesn't. He can defend himself.
Yeah,
and,
maybe I shouldn't have allowed questions.
But I wanted to be nice. I still feel bad that I missed his own event because I had COVID at the time. But now I'm missing Ronitt's event because I had flight cancelled. But so I wanted just to say something nice.
Thank you so much again. And let's thank all together, all the speakers collectively. All the speakers are there. Thank you so much. And unfortunately, I'm not going to be able to invite you to the break, but we're going to have a break right now. And also we have some mugs in the back. Don't forget to pick up your mug. And yeah, thank you again. And we're going to step outside and continue in